Okay, this is a first video in using Python intended for students in 237 and in uh, 132. And there's another video that I'll refer you to that is a little more advanced, but this one is intended to just be the very first time you'd see Python to remind you of some things that are important in using Python compared with other languages like Java. So I'm sharing my screen here, and I just want to point out to you some resources, and I will have linked this in the message that was put on Piazza to advertise this video. But we're going to use the Anaconda version of Python. It doesn't really matter which one you use, idle or whatever, the IDE, but you want to have Python 3, the most recent version. And there's a bunch of different sites, YouTube videos, and so forth. There's a tutorial on the Python website, the official Python website, which is very good. Up through about 4.7.2 would be good to review. Here's some other sites that I've used, and there's a bunch of different reference materials, including this book, which is 1,600 pages. I don't recommend you buy that, but having some text or having some references nearby is often good. I like this text very much, Python for Data Analysis. It's when you've become a little more comfortable, but it goes through the major libraries that you need in data science, pandas and NumPy. I also have a number of tutorials on my YouTube channel and with corresponding notebooks, emphasizing notebooks again, about NumPy and using Markdown and so forth, LaTeX. And but for now, what you really just need to do is to get comfortable with basic Python. So we're going to open up. I'm going to use Anaconda, and once that opens up, we're going to. This is a library or a suite of different kinds of applications. Here are the notebooks. We're going to use Spider, which is the interactive console. So when this opens up, we'll see the basic ideas laid out for us. Okay, the most important thing to realize is the function of these two panes here. There's a file editor that you can use to create programs or load programs from files. And then there's this interaction pane, which is really the center of Python. Python is an interactive language compared with a language like Java, which is compiled. Interactive means it's like it functions, at least the interface functions like a calculator. You have, here's the very first thing I've typed in, 5 plus 6, and it prints out an 11. I can type in some very long expressions. It's very fast. But it functions like a calculator. You type something in, and it spits it out. Now, behind all of this, though, is the Python language. So there are things that we can do in this environment that involve the full resources of a programming language. This is just the interface. However, I recommend that you use a file, okay, to record your commands, basically write your program. And so what we're going to do, let me show you how that works, and we'll emphasize this idea. So there's a temporary file. Sometimes these are called scripts. A program for an interactive language is called a script because really what it's going to do, it's going to read through all of these and execute each line separately. So what we're going to do is create a new file, and now we can type things in the file, and let me show you how, say, a print statement works. And you see that it has all sorts of bells and whistles to help you write code. So this is just a simple program. You can leave this in or remove it. And what this is going to do is create our first program. The very first thing to notice is that the hash is the comment character. So when you want to have a comment in your program that's ignored, you start it with the hash mark. You can also use three single quotes. Three single quotes. And it's a little slow. Okay, it's catching up. Not sure why it's so slow. And I've started with three single quotes, ended with three single quotes. That's the way that you would write a long multi-line comment. And here is the short way to do one individual line. Okay, so I've written a program, such as it is, and I'm going to save it, and I'm going to call it Hello World. Very imaginatively. Python programs end with py. Just like a Java program ends in .java, this ends in .py for Python, obviously. I'm saving it, wherever I'm saving it. I don't know, desktop. And okay, now I've got a program that I'm working on. Here it is. And so basically what I can do is I can run the program and see the results over here, and I can go back and forth between the two, developing my program and seeing what it does. The workflow in Python is a little different than it would be in Java. In Java, you create your program. It's compiled into another language. For Java, it's called bytecodes. And then it's executed, and the whole thing is executed. Here, the style is more based on that kind of interaction that you see with a calculator. But here I'm just going to put a bunch of statements or expressions, whatever, that will be evaluated, okay? And it'll perform whatever you tell it to do. It's a program, right? So here I'm just going to run it, and you can see that it ran this file, okay? And printed out hello world. If I go back here and I want to fix the H okay, let me save it. Control S, run again. Okay, so you're going to go back and forth between these two. Now, I'm going to illustrate some of these things, but I want to go to the file that is accompanying this video. The very first thing, there's just 3 or 4 things that you need to really focus on in the very beginning, okay? The first thing is it's an interpreted language, which I said, and it accepts, basically it has 2 things it can do. It can make a definition, it can store a value, for a variable. It can store a definition, like a function definition for a function name, but basically it is storing variables or functions names in a global memory, and you are updating that as you go along. Most of the problems with Python, at least that I have to do with this global memory, forgetting that you have a binding in there. Python does a couple of annoying things with respect to this memory, but we'll talk about that in the other video. But anyway, here we have some definitions. This was run. You can imagine this being run in the program. I'm just showing an example here. This is a notebook. You don't need to know anything about notebooks. But here you can see I've made some definition. X is 4, Y is, okay, now I can use the value. Programming language assignment statements. Here, we're going to talk about lists in a moment. But my point is to show you that it establishes a list, actually a dictionary, which again we'll talk about in the other video, and it makes these bindings and it stores them in a global list. So, first lesson, now that you understand that it's going to store these bindings, Python is weakly typed. It does not have a strong type system. The type system is what says in Java or C++, whatever, that a variable x is an integer, and you can only store an integer in that variable. When you have an array, it has to be an array of some type, and you can only put values of that type in the array, and you're familiar with this from other languages. Python has a very weak type system, and this is often the case with interpreted languages. They're just a little more flexible, sort of befitting this idea that you might just log in and do a few things like a calculator. But in particular, the values, the data, always have types. This is a floating point. This is Boolean. This is a string. This is an integer. Values always have types. The question is, does a variable have a type? And is it declared once and for all with a type, as in Java? Well, in Python, that's not true. You do not have types associated with variables. Variables are just boxes that have a name. They can hold anything, and you can reassign them. So here x is 4. I print x. It prints out. X is 2.3. Print it out, it prints out. Now it's true. Now it's a list. You know, it can have anything in it. Now, types, of course, are checked when the variables are used, and you may have errors at execution time. Now, I recommend that you get used to looking errors up. If you get a type error, you can only concatenate. If you literally were to cut and paste this into Google and say Python error and spit this in, you'll get, somebody will help you. Somebody on Stack Overflow or somewhere has written this. There's a lot of helpful people, not in real time, but somebody will have answered this in the last couple of years. So, but the point here is that x, at the time when I evaluated it, is a string, and you can't add 4 to a string. That's not a legal operation. So you will get errors, and you have to think about, okay, what's the last value I assigned x to? This is different from a language like Java or C++. This would have been defined as whatever type, and before you even ran it, you would have seen this error. It would have been a compile time error before it gets to execution. And that's the big difference. Strongly typed languages, compiled, they do as much checking up front. Here, they delay it as much as possible. They only evaluate it by need. So that's the first thing to get used to, is there's very little use of types, and that means the onus is on you to keep your wits about you when you declare variables. Okay, let's just look at some standard syntax. You're going to have to look at a few examples, but really I spend 98% of my time writing for loops and if statements and IO, things like that, arithmetic. And let's just look at the main difference with a language like Java. The main difference in Python here is that you don't have this sort of free-form character-by-character format. In Java, this is written so that the carriage returns are ignored. Where the line ends and where it starts are completely irrelevant. It's relevant for understanding, for humans reading it, but the machine doesn't care. The computer doesn't care. You could put all these characters on a straight line and put no carriage returns, and it would be perfectly happy. It would interpret it. It would be hard to read for a human, but the machine doesn't care. And so they use these delimiters, like, you have parentheses in an arithmetic statement. You put these curly braces, and that says if, and then you have this expression which is evaluated true or false. If it's true, it goes inside here and it executes all the statements, and each statement ends in a semicolon. So you can see that there are characters in here that tell you what the spacing is, what the formatting, where things are, what the code blocks are, and they control which statements are executed. Now, that's not done in Python. It was designed to be as simple as possible to learn, and so they actually go back to, it's not an innovation, because the very first programming one of the first programming languages, Fortran, did this exact thing. And then they gave up on it over time and they started doing things like this for other reasons. But you don't, in Python, you do not have an end of a character which indicates the end of the line. Doesn't exist. And you don't have these curly braces. Instead, here's what you do. You have the first line here, you put a semicolon, and the semicolon says, okay, there's about to be a block, a statement block, and then you indent. This is one tab indented. It's a little bit flexible as long as you line everything up, but I recommend that you hit the tab so you know everything lines up. If you're typing in the editor, and I'll show you in a moment, it will keep track of all this stuff. It'll help you. But the point is that it's the indentation which tells you where the code blocks are, not something like this. So you don't have to go back and forth and check to see which bounce is where, and if that always annoyed you, you're in good luck because it's all how it lines up. There are other problems. Sometimes it also does annoying things. But in this sense, it's more like an outline. You know, you have an outline and then you indent and you have some pattern, and then you indent nested lists. It's more like that. And you can see the structure of the program very well from where the indentations are. It's a good idea. Just remember that you're going to have this colon, which introduces this sequence of statements. And these are only going to be executed if this is true, just like for this. So here's some examples, and here's the syntax you need to know for the if statement. Simple if statement: if x is greater than 2, print x is greater than 2, x1 is greater than 2, prints it out. x1 equals 5, standard assignment statement. Notice the assignment statement does not have the colon there that you'd have with Java. It can sometimes get confused with the equal operator, equal. The Boolean operators in general are the same, except that you spell out and, or, and not, use words. But otherwise, the relational operators are the same. Here is x2 equals 1. Here is an example of an if-else. And you have the if statement. Keywords are put in green. It'll color code them to tell you. And else has the colon here. So if, else. Line up if and else. Line up what's inside the code blocks. Remember to put the colon, no semicolon at the end. Okay. What about an else if? You go if, else if, else if, else. Nested if statements. It's elif. Languages have different abbreviations. You know, sometimes you say else if, sometimes they allow you to combine else if and ELS. They use elif. Fine. You just have to memorize that. Luckily, when you type it in, it'll turn green depending on your editor, and you'll see that you have the right things. You just have to remember if, else, and elif. And line things up. So here it peels off. Is 7, checks if it's less than 2. Is it less than 5? Is it less than 8? Yeah, it'll print out 5 as later it prints this out. So just remember if, else, elif, which is another condition, so it has the colon at the end, and else by itself on the line. Line these up. And if you were to put if statements in here, nested if, you'd line them up. Okay. We'll look at loops in a second, but the third lesson, the thing that you really need to understand, is that lists are the primary data structure. Lists are, in many respects, they look like they're arrays. Literally, they're not arrays. They're lists, which are made. They're more like linked lists that you studied in 112. But basically, the syntax is opening brace, closing square brace, commas in between, and you can, that's the literal way of writing a list. You can access it and add things. We'll get to that in a second. But the point I want to make here is that this is all integers. This is all strings. One little comment, I'll keep throwing these in, but you're going to have to just spend time learning the differences. Strings in Python can have a single quote. See, multiple characters here. It's not just for characters. It's for strings. Here you can have double quotes or single quotes. Most real Python programmers use the single quotes. It's more Pythonistic. But notice that you can have, A must have been defined up here somewhere, but that you can have different types. Here's a string, here's a Boolean, here's a list. You can have any kind of types because it's weakly typed. So here's A. Here I can print out the list. It prints it out. It puts the single quotes, and so forth. Now, in large measure, your intuitions about arrays in Java or C++ will stand you in good stead here. If you want to access, here's B. Hi there, Paul. And here you have an access using an index, just like an array. This is 0 index. This is the location of index 1. This is 2. It goes from 0 to 1 less than the size, just like in an array in Java. So I say print out 2. It'll print out 0, 1, 2, and it prints out Paul. Python also has a number of different ways of accessing lists. It's much more flexible than Java. And in many respects, you can sort of think of it as linked lists. They're not implemented, in fact, with linked lists, but that's not important. Here's one thing you can do. You can count backwards from the end of a list. -1 being the last element of the list. Print out Paul. If I said B -2, it would print out there. So you can count from either end, which is very useful sometimes. You can also use ranges of indices. Now, a range is going to be based on the idea that there's a beginning and an ending point. But think through what happens with an array in Java and what I just showed you here. It starts at 0, so the last index is 1 less than the length. And if you went 0, 1, 2, 3, the length of a list would be the next spot after the end. And that's true in Java as well. And so you write, for int I equals 0, semicolon, I less than 10, semicolon, plus I. You would write that in the 10 is the length of the list. And remember that idiom, I less than 20, and that's an idiom you learned in Java. It is carried, and every other language based on C uses that kind of for loop. So in the same way here, whenever you had, in that case, the beginning was 0 and the end was 10, but the first one was included, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the second limit, the end limit, was exclusive. Inclusive and exclusive. So it doesn't include that last number. It ends before because it's based on that C notion of a for loop or Java. So that's what happens here. 1 colon says from this to, it separates the beginning and the ending. This just, the default is go to the end. 1 to the end. There, Paul. See, it grabbed and it created a sublist. You do this all the time in Python. It's hard to do. You can't really do it very readily in Java. It's not designed that way. Now, here is an example of an index which starts at the default, which would be the beginning, and it says 2. It goes up to 2, but not including 2. So what's it going to do? It's going to go 0, 1, and not include 2. The second boundary is exclusive. It does not include that value. So what are we going to get? We're going to get hi there stops, right? Because 2 is not included. 1 to 3, you're going to get 1, 2, not 3. If it runs off the end of the array, it doesn't give you an error. Unlike Java, there's a lot of things that you're going to like about Python. It doesn't give you as many errors for things like this. 0, 1, 2, right? If you were to make this 10, would work perfectly well. But anyway, this is 1, 2, stop, and that's 0, 1, 2, and it goes to there. My point was you could have put 5 here and it would have worked just as well. Here's Here's one where it gives you the whole thing. This is a good way of making a copy of a list, actually. This is an iteration from the beginning to the ending, and the defaults are the beginning and the ending. It's the whole thing. Now, there's a whole bunch of different functions that work on lists, but let me show you one. len is the length of a list. You can see 3 here. Length of b is 3. So let's use this now in loops. While loop is the simplest thing in the world. It's exactly like you had in Java. You execute the statements while you get to here. While this is true, it keeps looping and then tests it again. It goes through and it's exactly what you studied in Java, with the caveat that you have this colon and indentation. It's the same exact meaning, same kind of loop. Here you start at 4, while x is less than 10. You're going to print x. Now, again, I'm going to throw in a couple of these little things. Python has all the standard operators. You'll have to maybe have a cheat sheet of things to look at, but it basically does everything you expect. One thing that you can't do, it doesn't have plus plus x, or x plus plus, or minus minus. It doesn't have any of those. It doesn't have those single line statements. So you have to do plus equals. X plus equals 1 is x equals x plus 1. Just write it out if you're at all confused about it. But it doesn't have this. To increment, you need to do something like this. So there it goes all the way up to 9. Doesn't include 9 because the indication of the end is not inclusive. Okay, now for loops are where you really spend most of your time, though. I think I haven't written a while loop in a long time in Python. I use for loops because you use arrays. I mean, you use lists. So here's the fundamental idea of a for loop. For, notice it's in green, it's a keyword. For k in, now this is exactly the same as for k equals 0, semicolon, k less than the length of a list, in this case 4 plus plus k, in Java. For k in is like the, the epsilon, the set membership. For k in this list, print it. It goes through 1, 2, 3, 4, 1, 2, 3, 5. Now that is the canonical way of doing it. However, you can produce lists using a range statement. The range will produce the indices according to the rules we just talked about. If you give it one number, it assumes it's the end of the list, and so it's one more than you want, right? It's non-inclusive. So range will start at 0. It's designed to create lists of indices for accessing lists. So range is 0 all the way up to 9 because it starts at the default, which is 0, and stops right before the ending of this. Okay? Now, if you just say range, it'll give you some gobbledygook here. If you want to actually look at the list, you put it here. You don't need to do that in general, but I'm just saying to view this, we needed to do this. Here is range 2 to 10. Now, it starts at 2. And again, it ends just before 9, 10. That is at 9. I can also skip, I can tell it what the skip is. So I can do range 2 to 10, but let me skip by 3. So that's like in Java, you said x equals x plus 3 as the third statement in the first line of a for loop. So here it goes 2, then it adds 3, it goes to 5, then it adds 3, it goes to 8. It's not yet less than this. Then it adds 3 and it goes to 11, but 11 is more than this, so it stops. So this creates this list. Okay? Now, the point is that you will use, here's the focus on this like a laser. You are going to use these range statements to go through the list, through the indices. And so I said for k in range length of L. Well, that's going to simulate the for loop that goes from the beginning to the end but doesn't include that last value because it's bigger, right? So I put length of L here. Okay, L is length 3, so length is going to be 3 here. It's going to be range 3, and that's going to go 0, 1, 2. I'm printing the indices here. If I wanted to print or access L, I would have put L square braces, and I would have manipulated it in here. So remember that when you create a for loop, you generally specify the range of the indices, and then you access the elements of a list. Okay, fifth lesson. To define functions, to encapsulate your thinking, you'll use the word def. Stands obviously for definition. And here we had a bad page break, but basically you can define a function, okay? There's no types, so you don't need to put int x here. But otherwise, you define the first line gives you the function name and the arguments with no types. You have to use the colon, and you have to indent. So here's a better example. Let's look at this one. Definition, space here. This is a keyword. You start with the word def to define a function. Here's the name of the function. Here's the argument. Here's that colon, which introduced the code block. Now you indent the definition. So what does this do? It'll return. The return statement is how you return, just like in Java, you return values from the function. So this takes x. It does a mod 2. If the result is 0, then it's even. It returns true. I put in a 5. It came through here. This was false. It went down and returned false. Okay, so if you define functions, okay, it's always the same pattern. Here, this returns a string, and we'll look at strings in a bit, but you're going to have to get used to the operators. One of the most useful operators on lists is plus. Let's get to that in a moment. Now, to use almost anything practical, you're going to need to import usually some libraries. Here's pandas, which is something was talked about in the in this book in detail. But Seaborn is plotting. Matplotlib is normal plotting, and you can look in my Python for 237 book notebook to see that. NumPy is a high-performance library which actually uses real arrays, and you have to define them as having a particular length. And like in Java, they have to have one type. So this is a way of using more normal, you would say, arrays in Python where the length has to be fixed and they have to have one type. Why do that? It's more efficient. If you constantly have to do type checking, every time you use an array, you have to look, and that's slow to keep checking the types. And so this is a high performance kind of environment for doing whatever you want to do. But NumPy is very, very typical in data science. Now, here's another one. Here's the syntax. You can import a library here's the shorthand, pandas as, and that means later on when I use this, I would say np dot to refer to some member of that library. Here I'll import math. I had trouble with that, I showed you. Sometimes, from this particular library, you just import one function. So you see a variety of these. Now, Python allows a lot of flexibility when you define functions. In particular, it allows you to, say, have a variable number of arguments, and bring them in as a list. So let's see what happens here. Sometimes it's useful to have a variable number of arguments. This is not a list. These are separate arguments. So what this is going to do, I call my sum and I give it all these values. When it comes in here, this sequence is put in a list. All the arguments, look, and actually a tuple, which is a little different kind of a list, but basically tuples have a fixed number of spots. You can access them the same way that you do arrays with 0, 1, 2, and so forth. They behave very much like lists. except you can't change the contents. But in any case, here you see my sum. There's essentially a list. You can count the number of arguments. You can, grab the last one and so forth. For this one, it is giving you a tuple, but a tuple of one argument. If you ever see this, this means it's kind of like a list with one argument, called a tuple. And that's a tuple with one argument. Here's an empty tuple, and so forth. More useful, perhaps, is the idea that you can have optional arguments and give default values. You're going to see this quite often. Here is something called LC hash. I'm going to call it here with 4 arguments, X, A, M, and B. You can see how these are going to be, 5 goes to X, 3 goes to A, M gets 7, and B gets 1. But if you leave these out, see these assignment statements here? These are default values. If you leave them out, it will use these. You see this quite often. You have to give the first one because there's no default. But here you can see that here I've given 15 and 3. It'll assign 15 to this. A will get 23. And you left out M and B, so M will have this value and B will have this value. You can give any number of these, and if you leave them out, it will use the defaults. Probably you don't want to mess with that too much until you become more comfortable, but you can basically, you can either put them in order, or you can specify with an assignment statement here inside the call what the value should be. Anyway, let's talk about how to manipulate lists. These are one of the most important things that you need to know how to do. There's a whole bunch of different functions which you can get used to, a bewildering number of functions to manipulate lists. For example, there's we had hi there, Paul. And if you look for where is there, the index of there is 1. It was, remember up above, it was hi there, Paul. I wrote this when I was working with Paul Hagstrom in linguistics. Now, you can assign a new element into the list and it will change it forever. This is just like Java, right? You're replacing this element. Now we have the list, hi there, Hagstrom. Now, one of the things you can do with lists is modify them on the fly with an array in NumPy or an array in Java. You can't do this. You have to fix the size, but that's not true in Python. This is one of the most important things. You can modify the list like this interactive kind of environment. You can modify the lists and expand them or shrink them. And the way that you add things, the way that you concatenate 2 lists and put them together is using plus. Again, this will feel more like what you did with linked lists in 1.12 in Java. So here's a list when you printed it out, hi there, Hagstrom. And I've taken this list. This plus here is an overloaded operator. Overloaded means it has at least two different meanings for different types. And it'll look at the types and it'll try to figure out what you want it to do. If the 2 operands are integers or numeric, it'll add them. But for lists, it concatenates them, it shoves them together. So this says C equals B concatenate and Wayne. And now you print out C and it says, hi there, Hagstrom and Wayne. Concatenated them. Now, B is still hi there, Hagstrom. So it shared the structure between the 2. You got to watch this sometimes because it's in the context of the interactive style. It allows you to keep adding things and you got to keep track of it. And the more you run it. Here, watch what happens here. I took C, hi there, Hagstrom and Wayne. I add another element to the end. C plus, adding an element to the end. print it out. Hi there, Hagsterman, Wayne, Snyder. I could also add something at the beginning, and now I'm changing C so it points to this new list. Well, plus C. Well, hi there, Hagsterman, Wayne, Snyder. I can also add a new element in the middle of the list. Again, this looks a lot like linked lists, right? The kind of processing you do. Here, let's go through this very carefully. This is C, which at this point is, well, hi there, Hagsterman, Wayne, Snyder. You have to keep track of what dynamically the meaning of a variable is. This is the complication with using this kind of language. It depends on when things it's in the calculator. So when did you define it? And what's the latest meaning that's stored in this global list of variables? So at this point, C is, well, hi there, Hagsterman, Wayne, Snyder. Here I make a copy of C012, which would be 012. That's, well, hi there. Then I make a copy here of 3 on, so 3, 0, 1, 2, 3 to the end. And in the middle, I put Paul, and what you get is, well, hi there. That's this part. Concatenate it with Paul. Now concatenate it with Hagsterman, Wayne, Snyder. So you can manipulate lists, but you have to watch it, because if you were to do this over and over and over, you would keep changing the list. It's worth looking at this example. So let me go back. Oh, where was it? Oh, I'll launch it again. When you do this kind of thing, you've got to think about what the latest value is, and oh, what's going on? Waiting for this to come up. Oh, here we go. Okay, so I can say A equals A, B, C. Okay, A, B, C. A equals A plus D. Oh, sorry. A equals A. I can only concatenate a list with another list, so it wouldn't let me do that. Okay, now A has a D added to the end. Now I could say A equals A up to 2 Oh, I have to make sure I make it a list. Now let me take A, let me make a copy of the first two, A, B, 0, 1. Then let you put middle in and then shove A at the end. So watch what happens here. A, B, middle, A, B, C, D. Now, you can use the arrow keys to go back and see, I can repeat. I just hit the up arrow key and it went through the previous commands. And if I were to repeat this, watch what happens. If I were to repeat this, watch. And when it gets long enough, it stops spitting it out this way and it goes this way. But the more I do this, it just keeps adding this, and I keep updating this list. I'm spending time on this because this is the workflow you need to think about, that you're taking a list and you are creating it, and you have to keep track of what the value is. If you run a program over and over and over and you keep changing a value and you don't initialize it, you'll get those kinds of situations. There are, sorry for shouting here, there are list processing functions which permanently delete things from a list. Try not to use those. Okay. So here, find the element. We talked about that. There are functions for sorting a list. For example, here is a list. Sorted, you're going to have to look up. Why isn't it sort? Well, I don't know. They use sorted. Get X, make it sorted. and you can see that it sorted the list. You can sort it. You can also use this sort of operation. Looks very much like object-oriented programming, where you have the dot to refer to something which is part of this. You can do that in Python as well. So this is a list, and if you say dot, you can call various functions. Now this is sort and not sorted. You're just going to have to look these things up. It can get annoying when you do 3 different languages and you can't remember. Here you can sort in reverse and so forth. So some types will have methods or functions, call them associated with them with the dot. Remember that when you pass lists as parameters to functions, you have now a reference to this list and you can change it inside the function. This is just like Java. So here I say the list comes in, okay, I print it, I get 1, 2, 3, 4 from this list, but when I call change list, it's going to take the first element and make it 5. And when I call this function, now it's changed the list. And I'm going to skip over this, but basically, if you make a copy of a list, you have to worry about how far down into the list you're actually duplicating things. And so read through this if you'd like. But let me skip ahead and talk about a few, at least mention 1 or 2 intermediate topics, and then I'll refer you to this document. A list comprehension is a great way to create lists. And basically what you're going to, bad page break here. Here is a piece of code. You're going to create a list. This is a list. The times with a scalar with an integer here says duplicate this 10 times. That's how you initialize a list with 10 zeros. There's a bazillion little pieces of syntax you have to learn. Just look them up or use one of the cheat sheets I referred to before. So here you've got 10 zeros in a row. For k in this range, length, which is going to be 10, you're going to go through and say lk equals, and you're going to take first 0, then 1, 2, and add 1 and then square it. So for the first one, you get 0 plus 1, 1 squared, 1. For the second one, it's going to go 1, you're going to go 2 squared, 4. So this is going to list the first 10 squares up to 100. Okay? Now, you see how we did it. We created the list, then we went through and changed it. You could have also created an empty list here and concatenated it on. Not very efficiently. The best way to do this is what's called a list comprehension. You can actually state what the contents of the list are based on a for loop, which you put in the rest of the list. Let's just go through this. Here is a list, beginning, end. This says it looks like this for each value in this range. So you can think of this as creating a list, 0, 1, all the way up to 9. And then this says, okay, here's the pattern. Now let me apply this pattern to those numbers, and it will create the list. Another way to think of this is like the set builder notation, curly brace, x squared bar, x greater than, you've seen this in mathematics where they create a set or a sequence by giving you the pattern and then the range of values. That's exactly what this is. So this will create, for these numbers, it will create a list consisting of this expression based on these numbers. You don't have to you don't have to call something that involves the index. Here is something called random. What it does is generate random floating point numbers between 0 and 1. It's from the random library, from random, which is a library, import random, which is a function. And it returns a random double in the range 0 to 1, including 0 but not including 1. And it will generate 10 of these. You didn't have to use k here, just like you wouldn't have to here. Wouldn't have to use k here. You could have put random here, and it would have filled this with random numbers. You can also use multiple for loops. D plus E for D in D, for L in L. This is a nested for loop. It's a lot. You can do a lot. You can do a lot. Okay? The other thing I would recommend that you learn about, sets are important, but is dictionaries. Dictionaries are one of the nicest ways to store information. They're very, very efficient. They are hash tables. It's a hash table. That's all it is. It's called a dictionary. It has a key, which is the hash key, and a value that's stored for that key. It's just a hash table. And so here is a dictionary that we create at the very beginning. It's got A is 2, C is 8, B is 1. If I print out D, it gives me the list. Here's an empty dictionary. And the dictionary operations are lookup. It looks exactly like a list, right? Lookup D, lookup the value associated with C. That happens to be 8. I can insert a new pair. I can say D of A equals 4. What that's going to go is go in and change this and make this a 4. It's like a hash table which has unique keys. Here, make an assignment, okay? Insert into the hash table a 4 in this location. That's what it did. But I can also add a new value. Hash with Z as the key, hash 23, put it in the location Z. There it is. It's a hash table. The fact that it's a hash table means sometimes you can't control what order things are in. That's not the point. It's for looking things up. So here you can update a value. I can grab the value for Z, and that's going to be 23. I can add 2 and then assign it to Z, so I've updated the value here. You can also remove things. Let's not worry about that. But basically, it's a great way to store information. It's usually better than using a list. And here you can just see the keys can be anything, by the way. They can even be other lists. You can get, and then there's a bunch of functions that go along with these. If you want to see all the keys, it'll print out the keys. If I want to make a list out of it, here's a list of all the keys, A, C, B, Z. Sometimes these are in the right order. They'll be in the order that they were inserted. And so you have to watch that a little bit. You can also get all the values. It'll be printed out in the same order that the keys were printed out. Don't depend on the order, though. See, 4, 8, 125, 4, 8, 125. There are also things like default dictionaries. If you want to, what happens if you want to access a dictionary but you don't know whether the key is there? Well, you can use a default. You can use what's called get. Instead of using this notation to get the value, you explicitly call D dot. It's like the object-oriented notation. The get associated with this data structure, think of this as a class in Java, get and find the value associated with this. If it's there, fine, return it. If it's not, here's the value to return. So this is a very useful thing. Okay, so I think I'll stop here. The rest of this has to do with floating point arithmetic, which for 132 should look very familiar, with some warnings about that. And then down here, I go into Python and notebooks. And if you're interested in notebooks, please do learn them. And I talk about in detail about how to manage the global list of variables. But what you're going to be doing is pretty much managing a program which you're going to run. And you can make definitions here, right? Def show results. And we're going to say, oh, I don't know, return x plus 4. Here I'm going to say print show results 10. Oh, too many. Oh, no, it bounced. It's good. And the typical thing that you're going to do when you write a program is to use print statements instead of letting it evaluate. You can do that. It's not very helpful. So you're going to have print statements. Here are definitions. You can see it's color coded. I'm going to save this. I'm going to hit Control or Command S to save it. And now I can run it over here. Okay. Hello world. Now it uses this definition and show results 10. But now these bindings, if I, let me do this again. If I, let's say A equals 34, let me save it, let me run it. If I run this file, A has a meaning. Everything that I defined here, show results, is now available for use. Everything I defined over here can now be tested over here. So the workflow here is going to be to define your functions, define your results, whatever you're trying to do, run it, and then get your results over here. You just got to watch it that you don't get caught into something like if I were to say, let's say X equals empty string, and then X equals X. Let's concatenate a 1, okay, and then I'm going to print X. Okay, now what is this going to do? It's going to do everything I had up here. Watch. Fine. And it's going to print out X. But remember, there's going to be a whole bunch of junk in there. I'm not going to do it. These values, these are stored, well, let me try it. You can see somewhere in here, here's A. Bunch of stuff is stored in here. But if I, there's X. But watch what happens. Ooh, actually what I want to do is this. Yeah. So now, if I run this again, I've made a definition for X and I've changed it here, and I've been deleting things in the middle of, an assignment. I just want to make a point, and I'm going to end on this, to watch out for, that you now are changing X. If I run it, oh, it didn't let me do it. Good. Oh, okay. Well, that's an advantage. So maybe this isn't such a problem. Maybe I should stop if I'm, yeah, there we go. Okay. It will not do the thing I was worried about. I haven't used this environment for a while. It won't let you, if you were to do it here, X equals X plus 1, right? It will do it. And if I repeat this, right, it will do it. But it won't do it when you run the program. Very good. So you don't have to worry about this so much. The main difference with Python is that it's interpreted. So you have to think a little bit about defining variables as you go along. Printing things out, okay, to see the results, just like in a Java. Lack of types, so you have to think about that a little bit. And the fact that you're going to use lists for just about everything. So, you can define a two-dimensional list here, and this is a list whose first element is a list and whose second element is a list. If you see the whole thing, it'll print out the whole thing, but now I have sublists. So if I want to find the first row, the second column, this should print out a 2. Yeah. So this will behave pretty much like you expect with two-dimensional arrays and so forth. You're going to use these quite often, at least in the linear algebra course. So you'll have some more experience with this. Okay, so I'm going to end here and take a look at the other video if you'd like some more backup. But I think this is the basically the most important things you need to know. Happy to talk more, and let me stop here.